All right, students. So I will take this topic of impulse momentum principle and law of conservation of momentum. But I will do only impulse momentum principle in this video so that you can focus on one idea at one time. My channel has a very long list of questions on mechanics. Please follow them. Okay, and I'm also putting a lot of questions pertaining to mechanics in my community. Join the community, join the community, you have to subscribe to this channel. So if you want to score well, you want to understand physics in a very simple manner, join this channel. So I will come to the topic of impulse momentum principle. Okay. So let's talk about impulse momentum, right? As a So first let's discuss what is momentum. Okay. So I'm assuming you have some understanding of momentum. For those who don't have understanding of momentum, I will just briefly write it. So momentum. So you can see momentum is a vector quantity. So whenever you solve questions on momentum, please take direction very carefully. It can be I, J, K, but momentum as a quantity is the amount of motion contained by the body given by product of mass into velocity and is a vector equation. Okay? The amount of motion. This is one. I told you I'm going to cover impulse momentum principle, okay, in this lecture of mechanics. Let's come to another concept, which is the concept of impulse. Okay. One of the most confusing topics is impulse. Let's discuss this. So impulse basically is the product of force and time. Okay, generally, time is very, very small, and the force is generally large. So, in the impulse equation, generally, the force is very large, and the time of contact between the two surfaces is very less. For example, if I hit this board, I touch the board for microseconds, and I received a very strong reaction force from the board. So the force is acting on the body for a very short amount of time. It results in a quantity called as impulse. Now, a lot of students have a doubt. When you say small time, what do you mean by small time? In reality, there is no small time. In some numericals, you will see the time to be 2 seconds. In some numericals, you will see the time to be 0.002 seconds. Right? So it depends on the numerical. There is no limit on what amount of time are we referring to. Okay. So it can be anything. Generally, we say it's a small time. How small? Depends. It can be in microsecond, millisecond, can be in seconds also, right? Now, what could be an example? So you played right tennis. So the ball hits the racket for a very short duration of time and rebounces, right? It rebounds back. So the force which is experienced by you in your hand, right? When the badminton or the tennis you play and your hand moves with it, when the shuttle strikes or the ball strikes the tennis racket, that force you experience is very large. Okay. And the ball has struck you for a very little time. Now the product of the force you experience and the time for which the ball stayed in touch with your hand is called as impulse. But today, we are studying impulse and momentum together. We are studying impulse momentum concept as a what exactly it is. Okay, so let's do one thing. So impulse is force into time, and what is force equal to? It is rate. The impulse is equal to force into time, and force is what? Newton's second law, change of momentum of the body. So when the ball hits you, the ball also goes back. So this is mu, the going back is mv. Momentum is a vector, and therefore when you go back, you put a negative sign. But this is change in momentum, right? So v will carry a negative sign. It will become mu minus. So in fact, so mv, this is negative, right? Velocity is negative. Put the sign very carefully there. So this is an impulse. The t gets cancelled. Okay. The impulse, in fact, is the change in momentum. You can see the equation, right? Force, as explained by Newton's second law, multiplied by time, time cancels. You get impulse is equal to momentum. Again, this is a vector quantity because, okay, so just be very careful about the directions, right? This equation, impulse is equal to change of momentum, is equal to force is the impulse momentum equation. You can expect a numerical in NEET examination pertaining to this topic. Okay, I will quickly revise it. We understand what is momentum. Then we write the expression for when you solve a numerical, how will you do that? First step, write the momentum, the initial momentum of the body, which is this. Then write the final momentum of the body, which is this. Okay, PF. P is momentum. So P final minus P initial. Multiply it with time. Sorry, P divided by time of contact. That will give you the impulse of the amount of force generated by this impulse. So if you want to find the force generated during this impulse action, P final minus P initial divided by time is the force. Okay. Now, if you want to calculate the impulse, the value of impulse, not the force, impulse, you will do change in momentum. So, change in momentum is equal to F into T. Right? So, there are two ways to write impulse. One is this change in momentum. The other is the force generated during the action of impulse and the time for which the bodies stay in contact. The badminton racket or the tennis racket stay in touch with the shuttlecock or the ball for some milliseconds. That time, right? So to solve this numerical, find out P, find out delta P, which is change in momentum. Write all of this. When the numerical comes in front of you, the concept is clear in your mind. You have to worry about delta P. You have to worry about J is equal to F into T. This is another concept you will write. And then you will say F into T. F into T is equal to change in momentum. That will give you the answer. So I hope you enjoyed this video. This is the impulse momentum principle. Please do not confuse this with the concept of law of conservation of momentum. In my next video, I will talk about law of conservation of momentum so that you can understand it and see the difference between the impulse momentum principle and the law of conservation of momentum. Thank you very much for your time. Do not forget to see my playlist on mechanics. Do not forget to subscribe to this channel. Thanks a lot.